Well, so I ask everybody to finish your work with contour lines. Well, a contour line is an imaginary line which connects points of equal elevation. Uh, so you can see that contour lines must be close, but not necessarily in the limits of the plan. Widely spaced contour indicates flat surface, and here you can see examples of these contour lines. Here you can see different methods of contouring. Direct and indirect method. Well, while um, uh, probably you know that on the construction field we use the grid of rectangular grid, so-called building grid, and it's often we use so-called method of squares. In this method area, we divide into a number of squares, for example, 5 meter to 5 meter or 10 meter to 10 meters. Levels of all grid points are established by leveling. Then grid square is plotted on the drawing sheet. Reduced levels of grid points marked and contour lines are drawn by interpolation. Method of cross section. For example, we have highway, and the axis of this future highway we uh, put the special signs or so-called pickets on the ground, and we create a number of cross-section. In this method, cross-sectional points are taken at a regular interval. By leveling, the reduced level of all those points are established. The points are marked on the drawing sheets, the reduced levels are marked and contour lines interpolated. You can see the example in the figure 17.7. It's typical planning of this work. The spacing of cross-section depends upon the nature of the ground scale of the map and the contour interval required. It varies from 20 to 100 meters. Closer intervals are required if ground level varies abruptly. The cross-sectional line need not be always be at right angles to the main line. This method is ideally suited for road and railway projects. So this line is the axis of future road, and these cross sections help us to create contour lines. And radial line method. In this method, several radial lines are taken from point in the area, and then we Also, draw uh, isolines, contour lines to uh, show the relief of the surface. Here you can see the explanation how to make a interpolation counterpoints between the 2 points. Any of the following method may be used: estimation, arithmetic calculation, mechanical or graphical method. And you can read the article yourself and try to. Here you can see example of graphical method. We use so-called palette. It's a massive of lines on the plastic or on a sheet of paper, and then we just can rotate this palette and find the necessary number of counter lines between points A and B. So after locating counterpoints, smooth counter lines are drawn connecting corresponding points on a counter line. French curves may be used for drawing smooth lines. A surveyor should not lose the sight of characteristic feature on the ground. Every fifth contour line is made thicker for easy readability. On every contour line, its elevation is written. Sometimes not on every, but on every 10, 20, 30, 40, etc. After every 10 meters of 5 meters. If the map size is large, it is written at the ends also. And here you can make give the answers on the questions yourself after this chapter. And let's move on. The next subject is areas and volumes. Areas and volumes. The land is always bought and sold on the basis of cost per unit area. For road and railways, land is to be acquired on the basis of area. In the design of bridges and bunks, catchment area of river and nala are required. Thus, finding areas is an essential part of surveying. It may be noted that area to be found is the projected area. Units for finding areas are square meters, hectare, and square kilometers. Relations among them are 1 hectare is 100 to 100 meters. 1 square kilometer is 1000 to 1000 meters. or 100 hectares. There are different methods of computations of areas. It is possible to computate areas from field nodes. It's kind of books that you take with you while surveying, and you make sketches of the some areas. If the area is bound by straight edges, it can be subdivided in a set of convenient features and area calculated, but in most of cases the boundary may have irregular shape. Yes, here you can see equations for computations of area of regular features. Here is example for triangle, rectangle, and trapezium. Well, most of all, we need to calculate areas or computate areas of irregular shapes. For this purpose, from a survey line, offsets are taken at regular intervals, and area is calculated from any one of the following methods: trapezoidal rule, Simpson's rule, and here you can see trapezoidal rule. If there are n plus 1 ordinates at n equal distance d, you can see equal distance d, 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 d. And for example, it can be 10 meters or 100 meters. And then total length of line L is nd. Area of each segment is calculated treating at its trapezoidum. Referring to this figure, you can see the formula. Area of first segment is O plus O1 divided by 2 on D. And finally, by adding all such segments areas, we get total area. And the next one, Simpson's rule. In this method, the boundary line between two segments is assumed parabolic. The figure 18.3 shows the first two segments, in which boundary between the ordinates is assumed parabolic. Area of the first two segments, you can see how can we calculate area of next two segments and total. It is to be noted that the equation 18.6 is applicable if the number of segments are even. In the other words, if total number of ordinates are odd. If n is odd, then for n minus 1 segments, area is calculated by Simpson's rules, and for the last segment, trapezoidal rule is applied. Trapezoidal rule gives the better results if the boundary is not irregular to great extent. Simpson rule should be used if the boundary is highly irregular. This rule gives slightly more value compared to trapezoidal rule. In both methods, accuracy can be improved if the number of segments are increased. Here you can see example. Plot the following cross-staff survey of a land and compute the area. Here you can see the sketch of the land parcel, for example. And here particular features, triangles, and here is the result. Another examples. Computing areas from maps. If map of an area is available, its area can be found by the following methods. Approximate method and using planimeter. Approximate methods, the following three approximate methods are available for calculating area from the map. Give and take method, subdivisions into squares, and subdivisions into rectangles. Here you can see give and take. In this method, irregular boundary is approximated with straight lines such that area taken in is equal to the area given out. And you can see. Subdivision into squares. Similar to graph sheet, squares are marked on a transparent tracing sheet. Each square represents a known area. For example, 1 hectare or 10 square meters or 1 square meters. Full squares are counted. Fractional squares are counted by give and take approximation. Then the number of squares multiplied by area of each square gives the area of the map shows such a scheme. Thinner the mesh, better is the accuracy. And subdivision into rectangles. Here you can see graphical explanation of the method. And computing area user planimeter. Planimeter is a mechanical instrument used for measuring area of plan. Here you can see mechanical planimeter. Nowadays they make digital planimeter that make the same work, but the area of the parcel you can buy this kind of instrument, you can see, and you can here's a short explanation of digital planimeter. Demonstration. All this advertising. Well, you can uh, watch the demonstration yourself. An example of using planimeter. Advertising. You can see method. Just you just counter the necessary object with special looking glass, and then while the counter will be closed, this planimeter shows the area of the object. Here you can see the total area of the lake. However, um, this kind of area computation, uh, you can use it. And here is mechanical planimeter, method of using planimeter. Computation of volumes. The following three methods are available for computation of volumes. From cross-sections, from spot levels, and from counters. The first method is used for computing each work involved in road, rail, canal, sewage works. Second method is useful for finding each work in foundations of a large building, and the last method is useful for finding capacity of reservoirs. Well, computation of volume from cross-section. To compute each work, profile leveling is carried out along the center line of the alignment of the project, and cross-sectional levels are taken at regular intervals. Then the volume of each work can be found if the cross-section are determined. First of all, the calculation of cross-section area is discussed. This area. If section level has the shape and size as in the figure 18.9, then we let H be the depth of the center line of the alignment, and 1 to n be the side slopes. And then we calculate W is equal to B plus 2 NH, So if it is a multi-level section, for example, we are speaking about highway, then we use coordinates of points. We arrange the coordinates in the following order, and then area of the feature. We have made this area calculation, and then calculation of volume. We just need one cross-sectional areas at various sections unknown volume can be found from trapezoidal or prismodial rule as given below, where n are number of segments at interval of d. And here you can see examples how to calculate volume. Prismodial rule, to apply this, we need cross-section at middle of the two sections. Assuming uniform slope, it may be found as the points with average coordinates. Hence, at midsection, the coordinates of the points are. And here you can finally calculate the volume is 2,230.67 meters, cubical meters. And next step, the computation of earthwork from spot levels. This method is used to calculate volume of each work for the elevations of basements, large tanks, and borrow pits. In this method, the whole area is divided into a number of rectangles or triangles. The levels are taken at corner points before and also after excavation. The depth of excavation at each corner point is measured. Then for each simple feature, rectangle or triangle. And finally, you can calculate this area. So, for example, you can imagine we just know the area of each rectangle, and the difference between the upper surface and the lower surface is the height of the prism. And then we just need to calculate the mean thickness of this prism and just area volume will be A divided by 4 on the sum of H1 plus 2 sum of H2 plus 3 of H3 and 4 of H4. And these sums H1, sum of depths used once, sum of depths used twice, sum of depths used thrice, sum of depths used 4 times. You can find these uh, points when we use the uh, depths once, twice, and 4 times. Here, these numbers explain how many times we use the depths of the volume. So, is it clear? You can ask questions. And here, if you have no questions, here you can see an example. 60 to 60 meters plot is to be excavated to a formation level of 80 meters. The present levels at 20 to 20 meters grid are shown in figure 1814. Calculate the volume of each work. The number of times a particular corner depth is used in volume calculation is marked in circles. Once, twice, 4 times, twice, 4 times. And then we use the formula and calculate the final volume of the groundworks. And the next subject is computation of volume from counters. This figure shows a dam with full water level of 100 meters and contours on upstream side. Capacity of reservoir to be found is nothing but volume of fill with water level of 100 meters. The whole area line within a counter line is found by planimeter. It may be noted that area to be measured is not between two uh, consecutive counter lines. So, and here you can see explanation of this example. Um, let A0, A1, A2, and AN be area of counters and H be counter interval. Then from trapezoidal rule, we just write down the volume is this formula, and by prismodial rule, another formula, where there are n segments and n is even number. And here you can see an example of different areas of contour lines, and assuming 100 meters as the bottom level of the reservoir and 124 meters as full level, we calculate the capacity of the reservoir using trapezoidal and prismodial formula. And questions. Here you can see examples of the same calculations. Well, is it everything clear about areas and volumes? Huh? In my opinion, all the stuff is easy because we are working with uh, particular figures and is it everything clear for you? Well, I think that we can take uh, some kind of question, some kind of mm, assignment, how to calculate area and volume of uh, so groundworks or volume of reservoir. Well, let's move on. Another next our question is our subject is curves.